All right, so this is for Algebra 1, and this is the exploratory challenge that we did in class today that a lot of us struggle through. So I'm going to walk through this with you, and then I'm going to do one of the homework questions. So at a state fair, there's a game where you throw a ball at a pyramid of cans. If you knock over all the cans, you win a prize. The cost is 3 throws for $1. But if you have an armband, which is like a wristband, that gives you a discounted rate. You get 6 throws for $1, and the armband costs $10. Write two cost equations for the game in terms of the number of throws purchased, with one without an armband and one with. So we're making cost equations. So we're going to use cost and the number of throws. Cost in terms of throws. So I know that depending on how many throws I get, that's going to tell me how much is going to cost. Depending on whether or not I have an armband, that's going to tell me how much it costs this. So I'm going to do this one, my first equation without an armband. I'm going to call it AB. And then with one with an armband, I'll call it AB. So my equation without an armband, and I know why a lot of us are confused. I know that C is going to be equal to something. I know that 3 throws cost $1. However, I need to figure out how much is one throw. And to figure that out, I know that one throw is going to be 1/3 of the 3 throws. So I'm going to write that C is equal to 1/3 of the $1, because it's going to be 1/3 of the 3 throws, and it's going to be 1/3 of the $1. Now I know that 1/3 of the $1 times T. That's how many throws. I know that this is only going to give me an answer when, or a correct answer when I'm doing multiples of 3, because they're only using 3 throws for $1. So 3 throws would be $1, because 3 times 1/3 would be 3/3, which is the same thing as $1. If I get 6 throws, then I'm paying $2, because 6 times 1/3 would be 6/3, which is the same thing as $2. Easy enough. For this one, it's a little bit different, because now the cost, I have to factor in the fact that they're buying an armband first that costs $10. And then this time, they get 6 throws for $1. So when they were getting 3 throws for $1, I used the fraction 1/3. So because they're getting 6 throws for that $1, I'm going to use the fraction 1/6t. Because every 6 throws, they're only paying $1. So if they pay the $10 for the armband and they get 6 throws, I would do 6 where my T is, and 6 times 1/6 will be 6/6, which is the same thing as 1. They would only pay $11. Now, when graphing this equation, I know it can be a little bit confusing, but all you want to do is graph it in a way that makes sense, so that you can plug in values for this equation and this equation and understand what is happening. So I was working with one of my students, and we noticed that the graph is wider than it is long, and so what we wanted to do was put the cost on the shorter side. I think this is what we did. The cost on the shorter side, and then the number of throws on the longer side. And for cost, I'm just going to count by 2's. And for number of throws, I'm going to count by, because both thirds and 6 are multiples of 3, I'm going to just count by 3's. 3, 6, 9, 12. I'm sorry. 15, 18, 20, 24, and so forth. So first thing I'm going to do is I'm going to graph my first equation, and I'm just going to plug in multiples of 3. So I know if the cost is, if I get 3 throws, the cost is going to be $1. Plot that point. If I get 6 throws, sorry, let me make this so you can see. If I get 6 throws, the cost is going to be $2. If I get 9 throws, the cost is going to be $3. If I get 12 throws, the cost is going to be $4. And 15 throws, the cost is going to be $5. And so on and so forth. Right? I can see the line forming already. Let me do a couple more. 18 throws, cost is going to be $6. Move that up a little bit. 21 throws, cost is going to be 7, 8. And I can already see the pattern forming. I can already see the line forming. I'm just going to roughly sketch that line. Now, I'm going to look at this. My second equation. I know if I get 6 throws, I'm already paying $11. I know I'm not going to be able to get 3 throws. If I get 6 throws, I'm already paying $11. So I'm just going to go to 6, and then go up to 11. Now, here we're going to count multiples of 6. If I get 12 throws, then I'm going to pay $12. Because 12 times 1 6 is going to be 12 over 6, and 12 over 6 is the same thing as 2. 10 plus 2 is going to be 12. If I get 18 throws, I'm going to be paying $13. If I get 24 throws, I'm going to be paying $14. And I can already see that line forming as well. If I get 30 throws, I'm going to be paying $15. So every time I go up by 6, I'm just adding another dollar. Mm, 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 mm. And I can see that line forming too. Just continue both of these. So it'll be much better with the ruler. 30, 3, 6, 9, 42, 51, and then 60. I just added these numbers to see like where the costs intersect. Does it make sense to buy an armband? So this question is asking, would it make sense for me to buy an armband? If I'm looking at this, if I'm only planning on throwing, I want to say less than 51 throws, then no, it doesn't make sense. I would pay less if I'm only playing the game for a short amount of time. However, if I'm fully invested in this game and I'm only buying the armband to do that, then if I'm playing this game for hours at a time, then yes, it does make sense. However, if I'm only playing it to pass time for maybe 15, 20 minutes, it doesn't make sense for me to buy an armband, which is going to cost me $10 when I can just buy maybe 21 throws for $6. I meant for $7. Or 30 throws for $10. That's just the armband cost right there. So there's that. Um, Another question that I want to do is, because we did something very similar to the first homework question, I'm not going to do that. Please reference the Tweedledee Tweedledum example for help with number one. Number two, I'm only going to help you guys set up the equation, the system for this. So please pay attention. The drama club at NAMS sells hot chocolate and coffee. Sell hot chocolate and coffee at the high school football games. At the last game, they had sales of $200. They need to keep track of how many of each type of drink was sold so they can make predictions for future sales. Monica knows that they used 275 cups that night, so that's total cups. If the hot chocolate sells for 75 cents and coffee sells for 50 cents, how much of each type of drink were sold? So first thing I know is that, sorry, that was Zoe. First thing I know is that however many hot chocolates they sold, I'm going to use H for hot chocolate, plus however many coffees they sold, that was going to add up to 275 drinks, because they used, I'm sorry, not 25, not 257, 275 drinks, because I know that they used 275 cups. I also know that 75 cents, I'm going to write that as 0.75, times the number of hot chocolates they made, plus another 50 cents, I'm going to write that as 0.50, times the number of coffees they sold, is going to add up to $200. And I got that information directly from here. This is the system that we need to solve. This is just like that question that we use for the number of coins. So think about that when solving this. Please be careful about these decimals. Please do not let them trip you up. If need be, use the calculators on your phones or whatever devices you have so that you're able to solve these accurately. I'll see you guys tomorrow.